Welcome to this explainer. Okay, let's just dive right into what is literally the ultimate balancing act in fintech today. On one hand, you've got this intense drive for unparalleled predictive accuracy. But on the other, you have the absolute non-negotiable need for strict regulatory explainability. Today, we're going to dissect exactly how modern financial institutions are actually pulling this off by building AI-powered loan underwriting platforms from the ground up.
Now, to understand why everyone is obsessing over this right now, just look at the ROI. The AI underwriting revolution is being driven by some completely undeniable results. Institutions that are deploying modern AI systems are seeing a massive 40% reduction in loan processing times. But it doesn't even stop at just speed. They're simultaneously hitting a 25% decrease in default rates compared to the old traditional methods. It's basically a win-win that is completely reshaping how credit is issued.
To actually get those kinds of numbers, you need a highly specific architecture. We're going to walk through this like a literal construction project, hitting 6 key phases: the AI underwriting revolution, foundation, policy, and data, brains, models and documents, the decision engine, guardrails, compliance and logging, and finally, integration, testing, and launch.
All right, part 1, the AI underwriting revolution. Let's start with why the old way of doing things just isn't cutting it for modern digital lending.
Let's be real. Traditional underwriting is completely bogged down by manual friction, and nobody enjoys staring at endless paperwork, right? Studies actually show that traditional underwriters are spending 30 to 40% of their day on purely administrative tasks instead of, actually evaluating risk. But when AI steps in and automates all those repetitive data entry and verification chores, the whole script flips. Financial institutions are reporting a 42% reduction in operational costs. And this automation isn't about replacing the human underwriter, it's about liberating them so they can focus their actual human judgment on the tricky, complex edge cases.
Moving right along to part 2, foundation, policy, and data. Steps 1 and 2 are all about setting up your ground rules.
Okay, step 1 is easily the most overlooked part of this entire process, but it is absolutely crucial. You have to explicitly define your underwriting policy. Think about it. If you don't write down your rules, the AI has literally nothing to measure against. You've got to clearly document your risk thresholds. We're talking minimum credit scores, acceptable debt-to-income ratios, auto-reject criteria, the whole shebang. Because if you train an AI model on messy or non-existent rules, you're just going to get messy decisions. That documented policy is the ultimate rulebook your algorithm is going to follow.
Once your rules are locked in, step 2 is gathering and prepping your data. You take all that raw historical loan data and run it through a super strict sequence. You're cleaning out missing fields, doing label encoding for categorical data, and feature scaling so all your numbers carry the right weight. But crucially, you have to fix imbalanced data. Usually, you have way more good loans than defaults, right? So you use techniques like SMOTE. SMOTE essentially balances those minority classes, making absolutely sure your model is sensitive enough to actually detect high-risk borrowers, instead of just lazily predicting that every single person is going to pay you back.
Now this is where it gets really cool. Innovators are taking feature engineering to a whole new level. Look at how Revolut uses deep feature synthesis, or DFS. Instead of a human manually deciding which data points actually matter, DFS automatically engineers predictive features from really complex relational data. It can scan tables of employers and customer accounts and just automatically synthesize a new feature, like exactly how many employers a loan applicant has, using completely transparent math. So it builds up this massive predictive power, while totally avoiding that dreaded black box problem.
And then you have alternative data, which is just a massive game changer for financial inclusion. When traditional credit data is a little thin, alternative data steps right in to fill the gaps. Take the Argentine company Findo, for example. They analyze over 10,000 real-time data points pulled directly from cell phones. By looking at things like inferred income, social capital, and behavioral patterns, they can confidently score and offer credit to underserved applicants who legacy systems would have just auto-rejected on the spot.
That brings us to part 3, brains, models, and documents. Steps 3 and 4 are where we build the actual core of the operation. Step 3 is basically the great algorithm face-off. When you're picking your risk-scoring model, you're faced with a really tough trade-off. In one corner, you have logistic regression. It gives you around 88% accuracy and assumes a linear relationship in your data. It's a bit basic, but regulators absolutely love it because it's so easy to interpret. In the other corner, you've got XGBoost. XGBoost hits a staggering 96% accuracy and perfectly handles crazy nonlinear data interactions. The catch? It's way harder to explain. Just hold on to that tension for a second because we're going to solve it shortly. Alongside that risk model, step 4 is all about building a document processing layer using natural language processing, or NLP. Because seriously, nobody should be manually typing numbers from a W-2 into a spreadsheet in this day and age. By integrating NLP, your system automatically extracts data straight out of PDFs, IDs, and payslips. It's been shown to slash document review times by 68.2%. It literally turns unstructured text into structured, usable data for your models in an instant.
Which leads us perfectly into part 4, the decision engine. Let's see how this all comes together for step 5.
So, remember that tension between accuracy and explainability we just talked about? Well, here is how you actually resolve it, the two-model pattern. Inside the decision engine, you deploy your highly complex model like XGBoost or a neural network to make the actual highly accurate risk prediction. But then, you pair it with a constrained, simple, linear model that is trained specifically to approximate what the complex model just did. That second model exists for one reason only, to generate the regulatory explanation. It's such an elegant workaround. It keeps your risk officers happy with high accuracy, and it gives regulators the absolute transparency they demand.
All right, part 5, guardrails, compliance and logging, because a powerful engine is completely useless if you don't have brakes. Step 6 is installing those non-negotiable safety features.
You know, when classic move fast and break things software engineers transition over into banking MLOps, they usually freak out at how slow the deployment pipeline is. But here's the thing. The friction of a slow, compliant pipeline is entirely by design. The compliance overhead is the feature, not the bug. Moving fast and breaking things is absolutely not an option when you are dealing with people's livelihoods and incredibly strict federal regulations.
A massive reason for this in the U.S. is the Equal Credit Opportunity Act, or ECOA. Under ECOA, if you deny someone credit, you can't just shrug and say, well, the computer said no. You have to provide a highly specific, precise reason for that denial. A bank literally cannot meet its legal compliance obligations if it can't mathematically and logically explain the AI's exact reasoning for a rejection.
So, to survive that inevitable regulatory scrutiny, your system has to be built for an audit from day one. If a regulator walks in to review a loan decision made 18 months ago, you need to hand them 4 things immediately: immutable logs of the inference request, complete data lineage tracking showing the journey from the raw source right to the feature vector, a model registry detailing the exact version of the model that made the call, and finally, retention policies that lock all this down for a 7-year audit period.
And finally, we've made it to part 6, integration, testing, and launch, the final stretch with steps 7 and 8.
Step 7 is where the rubber meets the road, wiring up your entire AI tech stack. A production-grade platform isn't just one app. You're orchestrating a backend, probably Python or Java, hosting those XGBoost or scikit-learn models. You're tying into AWS TextTract or Google Document AI to read the files. And crucially, you have to build out API integrations to pull banking data from Plaid, credit scores from Experian, and pipe it all seamlessly back into your legacy loan origination software.
But hold on, before you actually hit launch in step 8, you absolutely have to implement rigorous testing. And we aren't just checking if the math is right. From a regulatory standpoint, you are legally required to monitor for disparate impact. You've got to watch out for population drift, make absolutely sure your model isn't unfairly penalizing specific demographic groups, and continuously compare the model's predictions against real-world repayment outcomes. It's all about ensuring algorithmic fairness.
So, building out this 8-step engine obviously gives financial institutions just incredible predictive power, saving millions and expanding credit access. But as these AI models become completely embedded in our financial infrastructure, it leaves us with one really vital, provocative question. When an AI makes the final, definitive call on someone's financial future, whether they get to buy that house or start that dream business, who is truly accountable? Think about that as you design your own systems. Thanks so much for joining me on this explainer, and I'll catch you next time.